Welcome to this tutorial on VSCode-PVS, the Visual Studio Code extension for the PVS verification system. I'm Paolo Masci, Senior Researcher at the National Institute of Aerospace at NASA Langley, and I will be giving this tutorial. The tutorial will cover the following topics: installation of VSCode-PVS, creation and editing of PVS theories, type checking and debugging of PVS theories, development of PVS proofs in VSCode-PVS, documenting your PVS files, and prototyping functions provided by VSCode-PVS. VSCode-PVS can be installed from the Visual Studio Code Marketplace. To proceed with the installation, you will need the following packages pre-installed on your machine: Visual Studio Code, Node.js, and you will need a Linux or Intel Mac system. If you have a Windows system, you will need a virtual machine with Linux. To install VSCode-PVS, open Visual Studio Code, click on the extensions icon located on the left side of Visual Studio Code. Search PVS in the Marketplace search bar and click Install to start the installation. The process will take only a few seconds. When the installation completes, you will see a welcome screen at the center of the interface and the PVS logo on the left bar. When installed for the first time, VSCode-PVS will try to locate PVS Allegro and NASAlib on your system. If they cannot be found, VSCode-PVS will download them for you and proceed with the installation in a base directory of your choice. If you choose your home folder as base directory, VSCode-PVS will automatically create a folder PVS 7.1.0 for Allegro PVS with a subfolder NASAlib in it for NASAlib. An additional folder Workspaces will also be created in your home folder that you can use to store your PVS files. To develop a PVS theory, open a workspace, create a folder that will contain your PVS files, and enter the theory specification in the PVS files. To open a workspace, click the blue Open Folder icon located in the Editor toolbar. A file browser will be opened that you can use to select the folder you want to use as workspace. After selecting the folder, the content of the folder will be automatically loaded in Visual Studio Code. If you want to create a subfolder in the workspace, click the corresponding icon in the toolbar of File Explorer. Finally, to create a PVS file in a workspace folder, right-click on the folder and choose New PVS File from the context menu. The created file will contain a basic structure automatically generated by VSCode-PVS. The structure includes a documentation header indicating the theory name, the author, and the creation date. There is also an empty declaration that you can use for your PVS theory. At this point, you can use the main editor to edit the theory. I will show some basic examples in the next few slides. For the simple examples shown in this tutorial, the PVS specification will be mostly self-explanatory, and advanced knowledge of the PVS language will not be necessary. However, if you need additional information on the PVS language, you can always refer to the PVS language, which can be downloaded from the PVS webpage. As a first example, let's try to define a new function abs that computes the absolute value of a real number x, and a theorem always positive that specifies a simple property of the abs function. In the PVS language, a version of the abs function could be specified as follows: abs with an argument x of type real. The function returns a real. If x is greater than 0, then return x. Otherwise, return minus x. The theorem is specified as follows. For all x of type real, abs of x is greater than or equal 0. As you can see, the editor supports syntax highlighting for language keywords and standard functions and types. For example, if, then, else, and if, theorem, and for all, these are all language keywords. Real is a built-in type. To view the definition of a type, or in general of a term, move the mouse over the term and the tooltip will show a preview of the definition. For example, if you move the mouse over type real, the tooltip will show a preview of the type definition from the Prelude library. Besides the preview of the definition, the tooltip includes also a link that you can click to jump to the location of the definition. To check type correctness of the developed theory, click the type check icon located in the editor toolbar. When type checking a file, PVS may generate proof obligations, also called type check conditions, TCCs, which are theorems capturing type constraints that need to be discharged to prove type correctness. To view the generated TCCs, click on the PVS icon. This action will load a PVS Workspace Explorer component in Visual Studio Code. This component shows theories, theorems, and TCCs generated in the current workspace, as well as their proof status. There is a play button next to each theory and theorem that you can use to launch the theorem prover and develop or rerun a proof. Before moving on to theorem proving, let's try to introduce some errors in the specification so we can observe the diagnostic messages presented by VSCode-PVS. For example, let's try to introduce a syntax error by changing endif into end. This error is automatically detected by the parser as soon as you save the file, and a tooltip reports the error message. Let's try now to introduce a type error, for example by changing the return type of abs from real to string. This error is detected when type checking the file, and again an error message is reported in a tooltip. Finally, let's try to introduce an importing error, for example trying to import a non-existent theory vector. In this case, you should notice that there is a quick fix action available in the tooltip. What is happening behind the scene is that VSCode-PVS uses heuristics to try to resolve the error. And in this case, VSCode-PVS is trying to match the name of the imported theory with all theories in Nasalib and in the current context. For example, these are possible fixes for this specific error, considering this case. The listed theories are all from Nasalib. Nasalib is an extensive library with thousands of definitions and proof lemmas that you can conveniently reuse in your theories. To assist you in finding definitions and lemmas in Nasalib, VSCode-PVS provides a search function. To open the search panel, click the NASA meatball icon in the editor toolbar. To search a string, enter the string in the corresponding input fields of the search panel and click Search Nasalib. The search engine will search the entered name in the entire Nasalib, including in both PVS code and comments. Results will be shown in a list, and each element in the list embeds a clickable link that you can use to jump to the definition. The list of results can be quite extensive, so you can use a filter to narrow down the results. for example, to view only type definitions or lemma definitions. Now moving on to theorem proving. To prove a theorem, click the inline prove action next to the name of the theorem. This action will open the prover console in the main panel and Proof Explorer and ProofMate in the side panel. Proof commands are entered in the prover console. A standard tab autocomplete function is provided, where proof commands can be autocompleted by entering the first letters of the command and then pressing the tab key. For example, S tab autocompletes the proof command into skip, which is a proof command for colonization. The prover console provides an integrated help shown at the bottom of the panel. The integrated help shows a short description of the proof command being entered, as well as the syntax. As proof commands are entered in the prover console, PVS builds a proof tree, and the proof tree can be viewed in Proof Explorer. Point-and-click actions on the proof tree can be used to undo, redo proof commands, fast forward, rewind to specific proof commands, replay proof commands, edit and copy-paste segments of the proof tree. Note, however, that editing of the proof tree is intentionally restricted in Proof Explorer because the tree is intended to mirror the internal structure created by PVS. If you want to freely edit the proof tree and create a sketch, you need to use the sketchpad provided by ProofMate. The look and feel of ProofMate is similar to Proof Explorer, except that editing is unrestricted in this case. Also, the content of the sketchpad is maintained across prover sessions. This is done to enable reuse of proof trees across different proofs. Besides providing a sketchpad, ProofMate provides also hints suggesting proof commands that can be used to make progress with the current proof. When a theorem is proved successfully, VSCode-PVS shows a message QED and automatically annotates the theorem in the PVS file with a comment indicating proof complete, the author of the proof, and the date of the proof. VSCode-PVS provides various functionalities for automatic documentation of a PVS theory, including the QED annotation I just mentioned for proved theorems, headers for new theories, and a pretty printing function for comments written in Markdown syntax. Example comments in Markdown syntax that can be rendered in VSCode-PVS are shown in this slide. They include mathematical equations, inline links, and also pictures. To view the pre-printed version of the theory, click the inline command View as Markdown shown at the beginning of the theory. A new view will be opened on the side with a pre-printed version of the theory. Several expressions in PVS are executable, and there is a component called PVS.io that can be used to evaluate such expressions. To start PVS.io, click the play icon in the editor toolbar. This action will open a new panel with the PVS.io console. You can enter the expression to be evaluated in the PVS.io prompt. For example, we can evaluate the results obtained by the abs function for -3 by entering abs of -3 followed by a semicolon. VSCode-PVS builds on and extends this evaluation mechanism of PVS.io with front ends for plotting functions and creating interactive prototypes. For example, say we want to plot the output of a function that computes the square root of a number using Newton's method. In the Newton method, we start from some guess a greater than 0 and then compute improved guesses iteratively. To plot the values computed by the function, we define a utility function that evaluates sqrt Newton n times and saves the results into a list of reals. And then we click the line action plot expression to view the plot. A new panel will open on the side with a 2D plot of the function. When a PVS theory describes the behavior of a system as a state machine, you can use the PVS.io web component of VSCode-PVS to create interactive prototypes that are visually similar to the real system and are driven by the PVS theory. PVS.io web allows you to load a picture of the system in VSCode-PVS and create interactive areas of the picture that can be linked to state attributes and triggers in the PVS theory. State attributes will be typically used for output elements such as displays, and triggers are linked to actions that can be performed with the device, for example pressing a button. You can find several such examples on GitHub at the link shown in this page. I would like to conclude this tutorial by mentioning that several commands can be conveniently triggered with keyboard shortcuts. These shortcuts start with the sequence meta x, where meta is the alt key on Linux and the option key on Mac. In this quick tutorial, we have covered the main functionalities of VSCode-PVS. Additional resources can be found online on the GitHub pages of the tool. There is also a Google group where you can ask questions and get help on PVS and VSCode-PVS related topics. Thank you.